So my name's Chris Zietlow. I'm from MindGrub, and we've started on this journey of starting to do more contextually aware, serving more contextually aware data and content to our end users. And it's kind of led us down this path of leveraging and integrating machine learning into our Drupal and even other existing web properties to create a better overall user experience tailored to our specific user segmentations or specific user roles. So a little bit about me. I'm a lead Drupal engineer with MindGrub. We are in the Baltimore area, but kind of run up and down the East Coast a lot with our client work. This is my partner in crime, who is not here today, Colin Crampton. This is started as an internal proof of concept, and he initially did some of the early prototyping work to get this idea from proof of concept to ready to start integrating in with some of our other customers. I said MindGrub's a shop. We're primarily based out of Baltimore, but we've got offices up and down the East Coast. We're a technical agency. We do Drupal and a lot of other stuff. And of course, obligatory, we're hiring. I think we're pretty cool. And I'll touch on this a little bit more later. Along with R&D, A&I, machine learning, we also recently have started building robots. This is Snacks in our office, who is on his way to delivering automated snacks via a Slack command. More on that later. So how did we get here? This has kind of been an area of interest for me since I was a little kid. And it started back, the first time I remember hearing about this outside of like an episode of Star Trek or something, was in the 90s. And that was when then Russian Grandmaster, the Grandmaster in chess, lost to a computer. And it kind of, there was a lot of hyperbole in the news, and they built the story up of our greatest minds can no longer best the computers. The computers are now at a spot where they're going to surpass the humans. And it was a lot of hyperbole and excitement, but it really got me interested in this overall idea. Not much happened, or really I went through being a teenager, but the next thing that really sticks out in my mind was in 2011 was the next time I remember hearing about artificial intelligence or machine learning in the news. And that was when IBM's Watson destroyed everybody on Jeopardy. We have now built a computer that can best us at our own trivia game. And Watson's then gone on to a lot of really cool things. And now we're starting to see we're kind of going out of this wild proof of concept idea, and we're finding more practical applications. 2012, Google's Lab X started building an algorithm to detect cats out of videos. This was an early proof of concept and was a fun idea that I'm sure was great to work on, but this actually dovetailed a few years later into helping them start to content ID and match what the content was on YouTube, a platform where thousands of years of content is updated every minute. There's no way to police this or for them to do any kind of content curation without involving the help of computer-aided classification, which is really neat. And then Google again, 2014. Sergey Brin got up and started talking about an automatic car that'll drive itself, and it was mind-blowing. And I think this is still ongoing. We're getting there, not yet. Not sure who's going to get there first. Apple's in the race now. Google, you've got Tesla's autopilot. This is hopefully in the near future, but it's just another example of where we're starting to find real-world applications for this kind of high-level machine learning and data processing. So I keep saying machine learning, but what is machine learning? And I love this tweet. Today I learned that just changing stuff in your program until it works is hacky unless you call it machine learning. I love this, and for the most part, this is largely true. If you can do it fast enough, it's now the new hotness trend. So looking at machine learning, I like to kind of cover what it's not. It's not magic. It's not going to solve all your problems. It's not going to replace any humans on staff. Specifically, it's not artificial intelligence. It's more machine learning, especially with the areas we're going to be looking at. It's more a subset of the overall artificial intelligence, much the way you would look at algebra or calculus as a subset of mathematics as a whole. We're looking at a small subsection of this pie. And again, it's not a replacement for really anybody in your team, regardless of what their job is. If their job is data analytics, this doesn't replace this. This augments them and gives them more insight to their data. And it's not Skynet. It's not inherently evil. Well, not yet. So what is machine learning if it's not this magic thing that fixes everything for us? Really, it's just about performing high-level forms of data analyst and doing some kind of predictive algorithm off of that. 1,000 times given X and Y, I expect Z, we can start to detect how likely we are to see Z based on various inputs. It's really good at data modeling. And we'll get into more of this a little bit later, but taking these massive sets of data that would take ungodly amount of time for a human to process and categorize in any meaningful way, and it's really good at breaking that up in whatever way we define is successful for the machine learning. For the most part, it's going to be using existing algorithms we've had in data science really since the early 90s, late 80s. These aren't new. What is new is the level of computing power we have available to plug up to them. And it learns. This isn't a one-time setup, and every time somebody inputs X, display Y. This is a system that will constantly learn and adapt based off your data modeling, which is an interesting concept, right? It learns. This isn't a one-off write and let it forget. How does it go about learning? That's a crazy concept, especially in web development. There's three main ways that you can think of machine learning as learning and adapting and getting more predictive with its outcome. You can break that up into three categories. There's supervised, which is where we understand as humans, as its engineers, as its overlord, understand what all the inputs are going into this, and we understand what the desired outcomes are. A good example is we can look at sports teams, specifically with like the Baltimore Ravens. We want to build something where we want to predict how likely they are to win. And we've got a litany of stats we can provide to it. We understand what those stats are. Are you home? Are you away? What's our defensive strength in the year ranked amongst the other teams? Is it raining? Is it not? We can plug all these in and start to get some kind of weird model where we can see Baltimore Ravens typically do poorly if they're away in the West Coast and it's raining. So that's supervised. Another good analogy to think of supervised is go back to school where you're going through a course. You as a student are going through a supervised experience with an instructor or a teacher where they know what the desired outcomes are. They know how to confirm how well you understand the results you're trying to seek. And at the end of the course, you'll be assigned a letter grade with how well you did. You'll get an A if you demonstrated excellent comprehension, or you'll fail if you need to go back and you really missed the entire point and we need to go back and retrain you on whatever the specific set is. That's what it is. It's a lot of, I think of it more as the hand-holding learning process, and this is largely what we'll be looking at when integrating it into our web applications. One of the other two, or other three, is unsupervised. This is we give it large amounts of unlabeled data. We don't know if this is relevant. We don't know really how it applies or how it affects anything. We generally understand the outcome we're looking for, but in this case, we're looking for it to find patterns that as humans aren't easily identifiable to us, or maybe we've never thought about as existing before. We're not going to cover a lot of this. This gets into complex data classification, and some really interesting data science. The third one is semi-supervised, and this is kind of a combination of both, where we understand one subset of the data, but we don't understand the other, and we want to combine using labeled data with unlabeled data and see how we can do some data modeling based on that. Again, largely going to ignore that for the purpose of this. So a fun real-world example of using supervised machine learning. This is a lot lower res than I intended it to be, but this is a fun hierarchy of how they do classifications of mushrooms. I don't know why this stuck out to me as much as it did taking an ecology class, but mushrooms have some pretty distinctive characteristics, and most time you can kind of follow this dichotomy of, is it poisonous, is it not poisonous? At this point we know. Again, asterisk, don't apply any of this and go eat mushrooms outside. This is just a general rule of thumb. But one of the easiest ones is all of the mushroom caps have spores, and the spores are a different color. A common test is they'll take the spores, they'll drop it on a piece of black and white construction paper, and they'll look if it's a dark or white color spore. Typically, if it's a white color spore and 90% of the classified mushrooms we have, we know it's not poisonous. If it's dark, we'll start looking at other attributes to determine if it is. At this point, we've determined all known mushrooms, whether they're poisonous or not. But with a model like this, where we know we have all these attributes of known, we could apply this to unknown, undiscovered mushroom types and determine with some statistical confidence whether or not it would likely to be poisonous based on all the data we have from the rest of the mushroom phyla, or it would be poisonous or not poisonous. Something more relevant with doing image detection, and this is a little bit of unsupervised, but it's really difficult to train a computer to understand what pictures are. The math and the algorithms that our own eyes and brain uses to stabilize images and interpret and determine what they are is extremely complex, and we're not great at it. So we can train computers, but they'll start identifying and keying off aspects that maybe we wouldn't, to determine if this is indeed a letter, what determines a letter from a number, what determines this 3 versus another number in the string, how do we know it's a 3 in this font versus another font. It'll start looking at like specific patterns in the curvature of the actual number. So one thing I'll keep mentioning throughout is with machine learning, it's all about giving it as much data as possible. With supervised, unsupervised, the more data you can provide your machine learning libraries, the better you can train it, the more accurate results will be. This kind of goes against the year of the GDPR and user protection, and I do want to take a moment and remember that while we're doing predictive analysis with machine learning and just sucking as much data as possible, at the end of the day, your users are still human beings, and you have to remove yourself from just the raw data and think about what you're collecting, why you're collecting it, and what the implications of that are. Something like grouping a user in a segment and figuring out, are they more likely to want this product versus that product, that's relatively harmless, but they use a lot of predictive analysis in the healthcare fields. Insurances will use this, a lot of, more and more some health agencies are using this. They've actually used Watson after his Jeopardy days to go on and do statistical analysis on different hospitals' medical procedures to determine which hospitals had better success rates over others, to determine which purchasing plans should be used for different equipment and medicines across all hospitals. But when you're collecting data like that and you're building your data source of users' health information, it's important to remember what the implications of that could be if that data were to ever get compromised, if you have a data breach, and just always keep in mind, you are dealing with real people and real user data. So with that being said and that in mind, always aim to collect as much data as we can to build up as useful models as possible. For machine learning, there are a handful of options. Like TensorFlow is a big option. That's Google's. AWS has their own. We started down this track of looking at an open source solution. It's under the Apache Foundation umbrella. Well, they were bought out by Salesforce, but they've remained open source and still contributing. We're looking at Prediction.io. We chose that for a couple reasons. Mainly, our data sources we weren't comfortable putting on the cloud due to the nature of some sensitive data. So we wanted an in-house stack that we could build. Prediction.io was perfect. So some key features on us that sold it were it's open source. Love that. We're largely an open source shop, so that fit in line with our development ideals. It already has a library of available algorithms that have been implemented, which is perfect. We have one person on our team that's overly familiar with Scala, which is what a lot of these deal with. But this opens us up to kind of the Drupal solution of likely what problem you're dealing with, there's already a module for that, and we can leverage that. And oftentimes, there's several different options from different people's opinions on how this problem should be better solved, all in the same problem space. It's easy to wire to web apps because it has a pretty robust JSON API that you can both read and write from, which is perfect with a lot of our D8 sites we were looking at using this with. We could very easily leverage the REST API within Drupal and communicate back and forth between Prediction.io and our web apps. Has an awesome mascot. That is a big selling point too. Which, fun fact, and I just learned this, they went with the frog logo because it's While not scientifically proven, it's largely assumed that frogs actually can predict earthquakes. This was evident when they had a lot of earthquakes in Asia around 2014. For no reason whatsoever, a lot of frogs were leaving their habitat, hopping across busy highways and interstates, and risking death to get out of what later turned out to be the epicenter of an earthquake. I'd like to believe it's true, but that's just a loose correlation. But that is why they have the frog logo. So Prediction.io, it is an independent web stack. You have some options. It is kind of pluggable, but it will communicate directly to your web apps if you're REST, which is a big win. It's composed of a handful of components. You're going to have an event server where you can store events and write events to. That's any kind of action that's happened, is happening, anything that you want to add to your data model, whether that's a user going through your site, maybe that's a user clicking on a product, maybe that's just product detail, or really anything that involves any data you want to send to be trained off of later. Need some kind of data storage mechanism. Out of the box, Prediction.io was designed to be highly scalable to the point where it's kind of cumbersome for some of our Drupal projects. By default, it wants to use Elasticsearch and HBase, which are wonderful tools, but extremely bloated and cumbersome, especially trying to jam these in a container and stick them out to all of our developers to spin up. For example, this entire stack, based on its default assumption that you're building this for high-level enterprise clients, needs a minimum of 6 gigs memory just to run on a MacBook. So there is cost. The good news is it is pluggable. You can skip all that. You can use MySQL as your storage engine. If you really want, you can just write to flat files at the performance cost that will cost. And then the last piece is the machine learning engine. This is our brain of our application, where we'll be doing a lot of the data modeling and the training off of. Here's a nice little architecture overview diagram. What's interesting is you don't have to have a one-to-one correlation between your Prediction.io stack and your web apps, and you don't necessarily have to keep that encompassed to one client or one website to one stack. You can share your stack between a website and a mobile app, which is really beneficial to us as well. And we're exploring this idea. We think it's interesting. I think like a lot of agencies, deal with a lot of clients in the same space that share a lot of the same user experience or data problems. Specifically thinking about, we do a lot of work with universities. They kind of have the same user path of, ideally, it's trying to drive users to new student registration or get users to their appropriate student forms as efficiently as possible. So we're looking at trying to share data across those and do some kind of predictive analysis on how we could better accomplish that on some of the websites for multiple universities. Real quick of some details on the actual stack. Your event server is going to run, like I said, on HBase by default. You do have other options. MySQL works perfectly fine at the scale we were looking at. This will act as the interface, as passing data between your web apps and your machine learning engines. This will act as a real-time read and write. It can handle the scalability. The engines actually are pretty computational attempts to train and do the redata modeling. So you don't want to be doing that every time there's a user action you want to add into your data model. But you can write it to the event server and determine how quickly or how often you want to retrain your engines based on whatever your business needs are. Next, you have your engines. This is the brain of the stack, and this has the nice benefit that we have in Drupal as well of the proudly invented elsewhere. So it typically will contain an implementation of one or more algorithms. I think today we'll be looking a lot at predictive analysis. There are things like sentiment analysis and natural language processing. I think do watch it. There's another session going on right now about natural language processing. These are really exciting attributes as well. Something where I know we're trying to gather as much information as we can from users on a site. We really like the idea where we can determine, especially from a customer service relation point of view, of what they're looking for, providing more context to our customer service engineers, as well as how angry are they, how upset are they about this problem. That sets our customer service engineers up for a much higher level of success. So we can query our engines to make our predictions. We can have different options for different predictive algorithms we're using. And we can also tweak those scores. Again, more data is the better. And this is kind of what the general data workflow will look like. Oh, that's super washed out on this. But the idea is we would send information to our event server. Maybe it's our product usage or how often our products are purchased. We would train our engines off of that. And then in the future, if we wanted to do like the product recommendation, we would just query our machine learning library and say, hey, users looking at the product with ID of X, and give us the most likely products they are to buy if they're looking at this product based off all the data you have. So demo number 1. I can't even fail at a live demo because I cannot connect to our Kubernetes cluster from here thanks to Active Directory. But I've accounted for this. So initially setting up Prediction.io, there are a lot of READMEs out there. I'll provide a link for it. We've got a sandbox Docker container you can have. That's just this monolithic stack in one container if you want to play with it. But typically the setup is you have some kind of data set or data source. You would set up all the dependencies, set up your storage engine, and then you would feed the event server your data source as an initial starting point. You'd have to go through and build this. A lot of because of the scalability, it's highly preferable that a lot of the engines are written in Scala and other compiled code. So you do have to go back to this process of actually building the code. Luckily, again, the libraries are pretty robust, and this more often than not, you won't have to get into writing too complex Scala. But once you do that, you have your engines built, you feed it data, you train it. It looks a lot like this. Unfortunately, this server is down. Luckily, I have a second one. So as I'm going through this, you do get a nice dashboard. It just gives a readout of how your engine server is doing, what the algorithm's doing, as well as you have some things you can tweak and configure. In this example, we had a product recommendation engine, which we have wired up to this. If you haven't seen this yet, this is, I consider it the spiritual successor of Commerce Kickstart. This is kind of the out-of-the-box solution that the Commerce guys have provided. It's the hipster e-commerce store where you can go and browse products with like reviews like this. I love it. So we've wired up this prediction engine to where we feed it some fake browsing data, and then the idea is as you click on one of these products, especially this page, we're then calling to our server and telling, I think in this case, we're not actually calling it how likely you are to buy this product. We're looking to relate products. Everything has a hipster rating. We're trying to find products within that range based on what you're looking at. Unfortunately, the server's down, but nope. If you've ever used Solr, so a lot of what we'll do is it will look similar to this. This is Postman, by the way. If you've never worked with a REST API, it's one of the best tools you can get. It's the hardest to navigate behind the back. There we go. So this is just what posting events look like. You don't have to give a unique ID, but this is an example where we were just writing a bunch of data to the server, which we could then train it off of and consume, which isn't largely important here. What is when we make a prediction to it. This is just a saved response. Basically, I can make a prediction and give it a product ID, and then I can get back a configurable array of products that are recommended based off their hipster rating. And this looks at products that were purchased along with this product, products that were rated along with this product, products that were reviewed along with this product. And we get this score of how likely and how high in certainty the machine learning is. This is all configurable, and this is decoupled from the Drupal architecture. So we leave implementation up to the web apps. If you want to display 4 apps, if you want to display 4 similar products, 2 similar products, you have that at your disposal. One thing I did want to talk about, I think I pulled it up in the dashboard briefly, and this is true with all machine learning. Okay. Especially with product recommendations, it's this idea of feedback loops. you can get into this never-ending cycle where you're recommending products based on your prediction engine to your users, and because you're recommending them, the users are clicking on them, and it creates this, it starts elevating things that aren't necessarily correct or the best experience for your users. You can introduce these feedback loops where it will introduce a random variance into it, so you'll have a little bit more organic of an experience. Okay, so back to the slides. Okay, you can build your own. This is going to breeze through these for the sake of time. I've mentioned it's very complex, but there is a huge library. Most of your plugins are going to be in Scala. There is a pretty well-supported Python library. There is a PHP library that looked like the project maintainer wanted to do it as a proof of concept. I wouldn't recommend it. It's not pleasant. It doesn't work well. There's also some, I think the best supported languages there are going to be Java, Scala, or Python. But you don't necessarily have to do this. A lot of these are built and they expose some configurations via some INI files. So you can configure how much random variance you want, how important buying products is versus viewing products, and that sort of thing. Here's a brief list of some of the engine options that you have available to you. There's a lot of opinions and options for similar products. Also, classification gets into taking a set of data and finding patterns based on some desired input. That's always interesting. I like to mention this just to start thinking about other applications around other than just predicting content or predicting products. Churn analysis, I want to say it was actually from AT&T, but a lot of cell providers will use this and they'll take in data based on what they're offering, based on what their competitors are offering, and they'll use this to determine how likely or how high their user attrition rate will be based on the current market trends and settings and their competitors. And they'll use this and they'll get some value where they'll have like a 12% user attrition rate where users are going to leave them for a competitor based on what somebody else is offering. And they were using this internally through the early 2000s. Once it dipped below a certain threshold, they would readjust their strategy and start offering something more competitive to get that number a little bit lower to help maintain as many users as they could on their platform. Data regression gets into more very deep data modeling. Won't go into that. And then natural language processing, which I spoke a little bit earlier about. We like the idea of maybe having a bot assistant help someone through an e-commerce experience. Or I've worked on e-commerce stores where they keep wanting to put the little automated bot chat to the users to help them through a process, and it's always got horrible pre-generated answers that I think makes the experience worse. We're working on trying to hook up some natural language processing to make that slightly more useful, or at least hand off to the customer service engineer after that bot experience of, this is what the person was doing, here's what they were doing on the website, here's what they've said. Also, they sweared at me 18 times, I think they're angry. Which is actually how automated call systems used to work. If you would yell and curse into the handset, they would elevate you in the queue based off assuming you were angry. Also, they sweared at me 18 times, I think they're angry. Which is actually how automated call systems used to work. If you would yell and curse into the handset, they would elevate you in the queue based off assuming you were angry. Until people found out, and then they stopped doing that because everyone was just yelling at the system to hop the queue. Right. We can also do some similarity. So back to the robot. This is a completely non-web related application, but segues next into my second demo that is working. But this is, as I mentioned, our robot that delivers snacks in the office. His name is Snacks, or its name is Snacks, I should say. But the idea is it lives in its little closet. We can send it a Slack command, and then it comes out. The interesting part is our office environment's always changing. We're getting ready to do another remodel in November. And it needs to be able to navigate through the office without destroying itself. We need it to not run over people. We need it to not run through any doors. So we built in a lot of mapping techniques. And we found that we started introducing machine learning algorithm into it to help it find a more efficient route through the office and start doing some predictive analysis of, we tend to have a lot of our scrums between 9 and noon, and one of the main hallways gets clogged up a lot because of that. So he's able to somewhat accurately predict, during this hour, a lot of people are going to be here. And this is a brief example of how that works. Full disclosure, he did decapitate himself a few weeks ago. This is a fresh rebuild with a new shell. But the idea is we send him forward in a straight line, and now we're going to be telling him we're going to be telling it to go back exactly where it came from. But at this point, we've put a human being in its way, directly in its way. And the goal is we want it to be able to interpret data and kind of figure out that there is a person. Please don't run over them. There's an easier option over to your left or your right. The person standing in the way is the main electrical engineer working on him. It's a lot of faith in an application. I thought I had the play speed up, but so that's kind of the idea. Interesting enough, that shuffleboard table is exactly what it decapitated itself on. It's really good at understanding there's something in front of it can't go if it's at a certain level. Previous iteration had problem with understanding how tall it was, and it thought it could go right under there. You could see the height difference. So this is a kind of neat visualization of what the robot sees. We don't have a lot of things in the way here, but it gets an idea of the hard walls of where it can and can't go, and then everything else is kind of a soft value. Like, it definitely knows it can't go through a wall, but if there's a human standing in front of it, it's got kind of soft edges, it's not small. It does this thing called cost mapping where it'll assign everything a value and basically just tries to navigate the cheapest route. It's much how your GPS works. It looks like there's 2 or 3 squishy humans this way, but this hall's empty, so I'm going to go this way because it's a cheaper efficiency to get through that route. And I think introducing machine learning, we were able to start finding patterns with our traffic flow through the office. So it'll start looking down some of the emptier halls and find less occupied spaces of the office over others. So next example, mindgrub.com. We, of course, applied this to our own website. So let's actually open this in a new tab. This is the MindGrub website. Actually, it's the MindGrub website from a few months ago when I took the snapshot, but it's the MindGrub website. So the idea here is kind of taking to the path mapping. We're wanting to apply this to our user experience through the website. Specifically, we were wanting to identify what segment we felt a user navigating through our content best fit into. For MindGrub, our 2 main categories are you interested in talking to us because of a web project, or are you interested in talking to us because of a mobile project? So it's kind of one or the other. However, our website supports a lot of content for both. We also are very involved in Baltimore, so we do like to promote some of the other work we do just within the city. So that's kind of demonstrated in the order we've selected by default for our banner. Light City is an app we built for Light and Music Festival. It's really fun. If you've never been, would recommend it. But it's more or less a navigation map that takes you to interesting points throughout, and it has some AR elements to it that will show you some fun facts about some interesting spots you found. Second slide is just a spotlight of a website we did. This was for University of Maryland College of Environmental Sciences. Third one is a case study for a mobile app we did. It's an audiobook app specifically targeted at long-haul truckers. So this is kind of what our marketing team decided this is what we want to put in front of our customers first. Now I'm going to come down here to the news page. Okay, I'm missing some images. That's fair. So just kind of take notice of these are just chronological orders of some news entries we've done in the past. I'm going to click on graphic audio because I'm interested in this mobile app and I read it. But now I go back to the home page. Well, I try to go back to the home page. Don't tell me both demos died. Do your job. I love verbose Java output. It's the best. Okay, so I go to the news, go to graphic audio, would read this. Oh no, okay. Well, that's fun. Both live demos, wah wah. So in a previous browser session, I did this before I ran out of memory for Java. Basically what we've done is we are doing text analysis, and it's text similarity engine. We're comparing text of everything a user goes through, and then we're contextually reordering content based off that. By clicking on the graphic audio, news article, we've determined 1, you're interested in mobile apps. 2, if that's what you're interested in, we're definitely going to show you the mobile app about graphic audio. And granted, this wouldn't be something that we would display to the end user, but for visualization purposes, we've determined this is a perfect match. This is content that's relevant to you. The content, the case study about a website, not so much. And then thirdly in there, we have nothing because this wasn't really talking about any of our tech stocks. This was just a community project. If you come here and you're interested in a mobile app, we're not going to be promoting our community projects to you.
So if I can stop it for just a second.
Go.
How are you pushing the event of what the user clicked at? Are you clicking it to the event server, or are you going to like your analytics server and pulling here's where they were and then you're putting the text?
Okay, so that's a good question. There is. So in this case, what we've done is we're preloading, and we're not really training a lot off this. We've taken a dump of all of our content and have fed that into the event server so it's aware, it knows what all of our content is, and then we've trained it and told it what it is. In this case, we're tracking in the user session the titles of content you viewed, and then on every page you hit, we're seeing if you have viewed anything. In this case, by going to the news page and clicking this, it stores that in my user session. Every time we're looking to load the recommended slides, we're going to then make a query to our prediction engine. Again, just it's a REST API call. We're going to do that, say, hey, they viewed this, give us the most similar, the most recommended content based off of these titles.
Okay, so it's pre-cached the similarity of all those different permutations of this thing's like this and
yes.
not like that and so
yes.
on.
And so that's more up to a business need. In our case, we train it once and we'll retrain it about every week or so. With product recommendations, we found that retraining it every couple of days is effective. It's just as your data set grows, it becomes more and more computationally time consuming to retrain it. So typically you'll retrain it and it'll do predictive analysis off of the model it builds from training.
And then on the Drupal side, I assume you've got a paragraph or panel or something that when it loads, when it renders, it's going back to the prediction engine and saying, give me the ID of this entity, and then parameter. Is that kind of the...
Yeah. The prediction IO has no idea what Drupal is, but it has the entity IDs at the end of the day. So another thing we do, and this maybe is a little bit more relevant, once we have that user session, we're also completely reordering our news catalog based off of that. So now all of our mobile app story, or all of our news stories about mobile apps and graphic audio will be floated to the very top. The rest of these you'll see are all mobile app related. And I'll have to go further and further down to find things about the website or something else of that nature. And this is, maybe this is a good example of just kind of the false feedback loop. All of our content tends to mention our own name a lot, so we get a lot of false results based off of that in this older iteration. But you can configure and train it to like MindGrub's not a very powerful world. Stop doing text similarity off of that or weight that very low. All right.
Does it handle things like, and this probably is the NLP session that you said I should have come to, does it handle things like, not contextual, topical similarity? So you and I can talk about two very similar things that use almost entirely different vocabulary in those two conversations. How do you rationalize that?
Okay, that's fair. This is a very kind of black and white example because the titles are word for word identical. depends on the engine. Some of the engines do have some awareness of natural language processing and can understand if you and I are talking about Drupal and the web and hosting, Linux is also relevant to that because it's kind of topically related. I don't know if our website's a great example for that, but yeah, you can have very loosely related content that aren't word for word just this. Any other questions? Sweet. Head back to the slides. All right, so I mentioned at the very beginning, we are an open source shop. It's kind of in our DNA. So we've updated the Prediction.io Docker images once already. I think we're getting ready to try to publish a more recent version off of a recent build. The current ones are a couple versions behind, which means there's some compatibility issues with most of the available engines. We will be trying to publish those out on our GitHub. We are working on open sourcing and kind of pulling out, not really pulling out, but cleaning out for an open source push, the Drupal Commerce project spin up out of the box with Prediction.io that can run side by side. So you can get in and play around with that. That actually, we've got a couple different product recommendation engines configured with that, all that have different tweak options. There's one that really lets you dial in how you handle the feedback loop. There's another one that handles what events in an e-commerce store you weight more, viewing a product, purchasing a product, or rating a product. So that'll be coming out. And then as we get some of this stuff unified across our projects, we're going to be trying to contributing any integration work back into the Drupal ecosystem as well, as all good and proper Drupal developers should. Handful of resources in case any of it was interesting. There are the slides. I know I'll put them up on the Atlanta Drupal Camp site. I also just tweeted out at them. So if you want, you can grab them there. And then I did link out to an earlier iteration of our Docker file that you can grab, spin up, and play with. It's not a production toy. Do not try to run anything in production off it. Seriously. So there's the engine. I've used this. I know there's a lot of them running around. This does work really well with Doxel for your Drupal development. In theory, it's just Docker Compose. I think in theory, you should be able to easily put it into Lando or DDev or any of the other situations as well. Or if you're just running Docker on its own, you could do that. Oh, there's not more of the robot. So that's it. Any questions?
Talk a bit about play around with some of these tools and overkit fitting, or what you can do to. And I mean, it seems like there's one of the challenges with this using these types of tools is that you actually have to do some of your own analysis around like what's going to be relevant in this context, and you may find that you're actually predicting off of the weather. That's not even an input that you're giving, but it's hidden in data that you.
No, that's a really good point. I think one of the techniques I like the best, especially with the web, and I mentioned at the beginning, this isn't an attempt or anywhere close to replacing anybody out of our marketing department that does this kind of data analysis. We found what's really useful is the idea of doing A/B testing, where you can have different iterations of trained models serving up different results, and you can kind of weigh the effectiveness against each other as well as doing it against kind of a human curated list. We had that with the product recommendation catalog when I was talking to someone about that. It was one department really felt like they knew what they wanted, despite even just looking at the Google Analytics data, we were pretty sure they were wrong. But being able to go with an A/B test of this is what just data, predictive analysis based off your data will give you, and by the way, here's the effectiveness rate of getting people through the checkout versus this person's elevating their own department a little bit more through self-importance. I think having that data at the end of the day really helps drive those conversations.
Does the Prediction.io tool set allow for you to feed that back through? So having it learn from conversions, for example, and do that A/B test?
Inherent, like out of the box, no, but yes, that's actually I think our number one use for that is being able to tie in more of that analytics data to determine how effective and help drive those user channels to the site. Yes?
Something I want to add to that I've used prediction IO, but in general, when you are trying to see this overfitting problem or bias problem, you do error analysis with the training set and your test set to see how errors are happening with training set versus development of test set and compare those. In one case, it could be just a bad algorithm, or it could be just overfitting to the training set. So that way, the training set errors are very low, but the test errors are really bad. That tells you.
Yeah.
Anyone else?
Oh, LO8. How long did it take? How much time did you spend on the predict IO side? How much time did you spend on building the Drupal pieces to pull it in? How much time did you spend on big architectural thinking?
So for the text similarity predictive analysis, we were able to hook that up to our site from start to stop. It took one engineer a full week. So an asterisk, Prediction IO is not the only tool. It was just one that fit another use, and we were able to get that kind of prototyped and working on our actual website within a week. I'm not sure that all of the problems would fall within that. And honestly, if you're not concerned about where your data set lives, which was the driving force for us in starting this endeavor, I think that you may be able to offload some of the architectural decisions with going with something like TensorFlow, or I can't think of the name of it, but I know Amazon's got a couple other competitive products in AWS, and just offloading that to like a scalable cloud solution. Anyone else? All right. Well, that's it then.